Welcome to the first episode of SBME Interfaces. Our goal with this show is to introduce you to the people that interface with biomedical engineering, from students and faculty to staff and industry, and everyone in between. BME is a broad field that encompasses so many different perspectives, journeys, skill sets, and backgrounds, and we're excited to share them all with you.
So today we're interfacing with Peter Zandstra, who has a laundry list of responsibilities from director of SBME to Michael Smith Labs. He's an entrepreneur, he's a scientist, he's a husband, he's a father. He's an enthusiast of outdoors, a former rower, maybe still a rower, builder of ecosystems. And I've had the pleasure of knowing Peter for 20 years, indirectly and directly. So we're very excited to have you here, Peter, as our first ever guest at SBME Interfaces, we're calling it. Hope you, as the big boss, enjoy that name.
Fantastic. Happy to be here.
So now I know you asked us not to make a big deal out of this, so I'm going to make a small deal out of it. I think we should open with congratulating you on your recent induction into the Canadian Academy of Health Sciences. So just a quick thing, how did that feel?
Yeah, thank you very much. Well, it's always an honor to be recognized by your peers, and I'm very appreciative of the opportunity it represents. I think for me, what is really special about it is that it signifies how engineers and bioengineers are having an impact on health sciences at the highest levels. And that's important because that's really what we're trying to do here in BME is start to allow biomedical engineers and bioengineers to both drive the questions and the solutions that are important for transforming health.
Great, and this recognition is timely, but also, as you mentioned, it'll be a big impact on the ecosystem. So Peter, something a bit lighter. What led you from McGill to UBC to MIT and then to U of T to your first academic appointment?
Yeah, so I mean, a couple of different things. At McGill, I was in chemical engineering. I had the opportunity to take a course in biotechnology, and that really opened my eyes to what engineers could do in the biology space. When I left McGill, I was quite involved in rowing, as you brought up at the beginning. So I wanted to go to a place both where I could get a good PhD and do rowing, and the two places I found that had that were Oxford and the University of British Columbia, where which is close to the National Team Training Center for Rowing Canada. In the end, science won out. The opportunity to work with Jamie Perret and Connie Eves on a project to learn to grow stem cells in combination with, the wonderful environment we have here in British Columbia for outdoor sports and activities, made it a showstopper. So that brought me to British Columbia, and then once you get into bioengineering, it's nice to have an opportunity to go and see Boston and Massachusetts Institute of Technology, where I did my postdoc, and I'm really thankful for that time. And the contacts and the opportunities that I built there benefit me to this day, and I think are an important aspect of the path that I've been able to forge ahead. So a number of different decisions along the way, but often driven by both a combination of how I wanted to live my life, but also how I think leadership in bioengineering could really be forged.
Is it true that some of your rowing teammates made the Olympics?
Yes. I was not one of them, but I rowed with some amazing and really large individuals. I wasn't able to keep up. Eventually, actually, I was rowing so much that I broke my ribs from pulling, and
Wow.
so my bone structure couldn't keep up with the forces that were putting on it. So that's when I knew it wasn't for me.
Does that mean like no regrets then, choosing academia over being in the water?
No, absolutely. Rowing is a great pastime and one that I still try to do every once in a while. I think academia and in fact science and the ability to work with students and discover new things is really what keeps me passionate.
Great.
Cool. Out of curiosity, what strategies do you use to balance like that kind of lifestyle? Like obviously you like being outdoors, you like to row, all that kind of stuff. Like do you still get the chance to do rowing while doing all of these other things that you have on your plate?
It's hard. It's hard, but I mean, for me, if I don't make time for that, I actually can't really make it through the day. COVID has been interesting in that it means that we can get up early and do something early in the morning and then be back at our desks by 8 or 9 o'clock quite easily. It's part of it's also recognizing what each of us need individually to be able to contribute more broadly to the activities we're in, and that's something that's always been part of my sanity, I guess, or mental health, I would say.
Yeah.
Would you pick tennis or rowing, Peter, if you had to pick one?
Gosh, good question. They provide different things. Tennis is wonderful, but so frustrating. It's like golf, right? You never can do it right. There's always another way to fail. Whereas rowing is more therapeutic, I would say.
That's good. So, Peter, you've lived in a number of countries, and how's that shaped you professionally?
Yeah, good question. I mean, I've been really lucky to live growing up in South America, in Colombia, and in Asia, and the Philippines, to me, I guess it's shaped me in a couple of different ways. One is I've always been very inspired, in fact, by my father's work, which was in agriculture development, where he made significant efforts to improve the lives of small farmers. And when you see the types of impact that science and those efforts can have, it's quite humbling, what we're trying to do sometimes in biomedical engineering. And I think seeing how broad benefit technologies and efforts can be to individuals in a variety of different circumstances and backgrounds has always been one motivating aspect. Another important aspect of moving around like that is it really brings out the strength in family, right? When you move around a lot, your core is who moves with you often, and I think that's been also something that has been, continues to be very important to me.
That's great.
Do you think that speaks to maybe your choice to enter the administrative domain in academia as well, like all of that world traveling experience?
I haven't related those two in my head. I think for me, part of why I'm motivated, the opportunity we have with the School of BME is really, how often can you start something greenfield from the ground up and take advantage of and learn from all the experiences that others have had over the last 15 or 20 years in a place that has such wonderful resources and such wonderful communities such as UBC. So what really motivated me and continues to motivate me is the type of impact that we can have on the Canadian ecosystem and on and really internationally. And in order to do that, you have to step up, and that really is kind of what that represents it. It's not for me, as Priam knows more than anybody. I have both strengths and weaknesses in terms of my administrative leadership. But at the end of the day, it's really the passion of what we can collectively do that motivates me the most.
So Peter, picking on this question has always been, when was that point that triggered you, like, I'm going to pursue more administrative? Because I mean, I take someone like Santa Ono. I mean, there was a transition. He's been administrative. You see this with a lot of people that become deans. And where was that point where in Toronto you're like, okay, there's a time for me, and I want to, because it's a very different mindset than being a pure researcher or researcher entrepreneur that you have been to this point and continue to be. But now you've added this layer on yourself.
Yeah, I think it really comes back to how do you scale your activities. So, you know, Payam, as you know, there was a significant scaling in activities through the Medicine by Design program that you know, we helped launch at the University of Toronto. And when you see the ability to take what you can do individually in your own activities and multiply that across many different people and a broader impact, it's pretty exciting. And I think that in some ways is what motivates me about BME, is how can we take the goals and the vision that we have and scale it across not one individual but a whole organization.
Mm-hmm. Absolutely. So Peter, one other thing to touch upon, and I'll hand it to McGill, is you talked about greenfield and startup, and this comes up a lot in SBME. So you've been part of a couple, and newest one is Notch Therapeutics. For the layperson out there, quickly, what's it about and what excites you about it?
Yeah, Notch is fantastically exciting. So it's a company that was co-founded by myself, Shreyas Shukla, and Juan Carlos Zuniga-Fluker, and the vision of Notch is to make T cells available for therapeutics and open them up in a way that makes them as accessible as possible. So we're engineering T cells from pluripotent stem cells for cancer and potentially other therapeutics. And it's been fantastic to see. You know, Notch has grown over the last 6 to 8 months now to a company with about 30 people centered in Vancouver and Toronto. And I've really learned a lot, you know, participating in this process and seeing it grow, and helping, you know, the team there reach their goals. So early days for Notch, but we're excited to see where it goes.
Mm-hmm.
Out of curiosity, why the name Notch? That's an interesting name.
Yeah, so Notch is the major signaling pathway that is important for T cell development from blood cells. So, and you know, it's also, we like to think we're a notch above. So,
I like that. That's good. So for me, leadership has always been a really important, almost school of study. And one of the things I've noticed through academia is this isn't something that is typically taught to like when you become a PI, or when you, for instance, start something like the SBME or even Notch Therapeutics. When it comes to your own leadership, do you have mentors or people that you follow, examples that you follow?
absolutely, and you know, I think having mentors and models that one uses is so important. But even then, I think you know, I think I'm learning more and more that leadership is an active process. It's not a passive process. There are ways of doing things. You know, there's experimentation in it. What works, what doesn't, and I think you know, I've benefited from a huge number of scientific and other leaders over the years that I continue to model my activities after. You know, it wouldn't really be fair to name them, because I would always leave someone out that's really important. But there are, you know, in Toronto and in Boston and in Vancouver, there are important people who I admire and I continue to look up to in terms of how to interact under various situations.
I'm not as humble as you, so I'll name part of one of our questions. So how does it feel to interact with, I mean, you have your former PhD supervisors, Jamie Perret and Connie Eves, global leaders in their field. We have Douglas Laufenberger on our leadership external committee. Fun fact, I use a textbook from him on a course that you taught us in undergrad. And I mean, there's people like Michael Sefton and others, and you've in some cases been their leader in some capacity. How does that feel? And you're sort of more junior in age than them. So how do you deal with that?
Yeah, it's a good question. I mean, you know, from my perspective, I think what makes those individuals and others like Janet Rassant so special is they have a vision of what they want to accomplish, but don't have an ego. And you know, they have, that's not really fair. They clearly have an ego, but that they have an overall understanding of how we want to reach the goals we want to reach, and are supportive to having movement towards those goals. So working with Michael Sefton, working with others in there, I think everyone learns from each other, and that kind of environment of mutual respect, I think, is something that really comes out when I think of those individuals, and that continues to this day. So it isn't, I think from my perspective, and I wouldn't speak for them, but you know, we're colleagues, and we respect each other and work together to reach common goals, and understand each other's strengths and weaknesses, and move to support each other through that understanding, which is kind of fun.
For sure.
Now, all these people that you mentioned, you know, that you've worked with before, and now you're sort of in a leadership role with them. I noticed that like not all of them are entrepreneurs, right? And this is something that you actively chose, and it is a scary choice to make to become an entrepreneur. What was it that they kind of put you on that path?
Yeah, I mean, in some ways, it's kind of entrepreneurship is the process of translating discoveries to impact, and you know, it's one way to do that. What I think it's really exciting about it is it's sort of part of the engineering psyche too. We want to think about how the discoveries we make have practical applications in society, and what, you know, that's the way that society, that's one of the ways that society is set up to receive these impacts. So that's one thing that motivates me. I think also, you know, we've been very lucky to benefit from significant investment and support from the government, and I think thinking about how that investment translates into things that are important for Canadians, better healthcare, more jobs, those kind of things, better training opportunities, better educational opportunities, is all things that are enabled through entrepreneurship and translation. So I think it's an important part of what I do, and it's fun. You know, you meet entirely different people, you get in a different environment from the academic environment, and I learn a lot. So I think you know, as long as I keep learning, then there's always something exciting to do.
This is another one of those instances of convergence that we've noticed throughout everything that you do. One person described you as having a knack for connecting dots that are seemingly very disconnected or very disparate. Yeah, where does that mindset come from? Is that strictly like an engineering thing?
I don't know. It's a good question. I think you know, I think one thing that attracts people to BME and certainly attracted me is you get many different perspectives. So, you know, you have someone that learned how to, I don't know, calculate the number of distillation columns in a reactor in their undergrad chemical engineer, thinking about how feedback control might affect stem cell growth. So, you know, by being able to have different experiences and different backgrounds, and kind of the diversity of those experiences really allows you to bring new ideas to things. And that's something that we're, you know, I think is really important for what we're trying to do in BME is bring people together who have different knowledge bases and take, create opportunities for that knowledge to synergize with each other to create new discoveries and bring those forward.
Peter, as you laid the path for SBME and it's going for, what do you hope or what do you foresee the future of medicine to be? And I'm looking for a realistic response in terms of, maybe we can even focus on in the cell therapy stem cell area. That's your bread and butter. And what does that look like in 10, 15, 20 years? Am I going to go to the clinic and get injected by cells by then? I know we get injected by certain things, but how's that look like?
Yeah. So what I see, and this is true for cell therapy, as molecular therapy, and even the design of devices. So because we have a much deeper understanding of the molecular and kind of structural underpinnings of biological systems, now for the first time we can start to pivot from a data gathering and observation point to a design and synthesis point. So how do we take that understanding and start to design therapies that are specifically constructed to target certain clinical needs? So in the cell therapy space, you know, we're designing new cells that have specific receptors on their surface that target certain diseases, but also may have other properties, you know, can stop proliferating when they secrete too many cytokines or die when they become unsafe. So this idea that is very ingrained in our biomedical engineering program, which is the kind of, you know, understand, predict, design cycle, can now be applied to new therapies. And I think that's really exciting. And we've seen that already in biomedical engineering from the very beginning with the design of new devices. But now I think we can extend that philosophy much more broadly to human interfacing devices, to new types of molecules, and to new types of cells and tissues. So I think it's pretty exciting where we're going. You know, the other thing that's happening is we're able to make more and more intelligent predictions from our data. And so whether it's sensors that allow us to make predictions about how we might prevent disease from happening or prevent certain issues from happening with respect to accidents and injuries, I think we're going to make a lot of progress there too. So you know, it's an exciting place to be, and you know, the only thing we're missing is more people to come up with new ideas. So we're excited for people to join us.
So before I pass it on to McGill to close us off, we have a fun nugget, and I wanted to know if this is true. Is it true when you moved to U of T and you were asked to your office paint color, you said go for it, and it ended up being flamingo pink? And how did that pan out?
It did. Yes, it turns out that paint was on sale. So, you know, I didn't really mind it, but actually it was funny because Nancy was helping me move in, and it was the snowstorm of 1998, I think, where the army came into Toronto, and we were carrying the computer up the steps in the old building, having to shovel the snow along the way. So yeah, the office didn't stay pink. I didn't really mind it, but my partner didn't think it was a good way to set up shop, so we repainted it.
Wonderful. Okay, so last but not least, then, what do you have going on right now that you want everybody to know about? Something that you're really excited about, maybe you can get people involved in.
Yeah, I mean, there's a lot going on. I guess, you know, at the school, we're building a new building, and this building really represents an outstanding opportunity for us to make a place for the vision of the school, where you know, entrepreneurs and fundamental teaching labs and research labs and core facilities and spaces for interaction with the ecosystem around Vancouver in biotech and biomedical engineering can interact with each other. So you know, I think it's going to have a huge impact, and it's something that we're working very hard towards over the next 3 or 4 years. You know, at a more specific level in the lab, there's all kinds of exciting things going on that are really thinking about how we can use our T-cell development platform and our early tissue modeling systems to understand and implement new biotechnologies better. So things like tissue patterning and blood cell emergence are really top of mind there.
Perfect.
Thank you, Peter, for interfacing with us. It was a pleasure having you as our first guest and being very candid. And wish you all the best. And I'm sure we'll see you again. Like in an hour.
Thank you very much.
Thanks,
Real
everyone.
pleasure.